I discussed the topic with Professor Yan. Looks like that we've decided on this topic. I think hopefully it will be interesting to the other part of the world. So this is the work that we've done for the Academy of Science of South Africa, but mandated by the Department of Science and Technology in 2017. And then the idea is to get the status of the research and development and innovation of electrical energy efficiency in South Africa over a period of time. And then they compiled a booklet, and then it is formally published. The book was actually launched last year in 2019. So even though the work was done in 2017, so the book itself is still quite new. So the majority of the work was done by the Center of New Energy Systems, which I direct. So I think today I wanted just to report that part of the work. And then there are other part of the work which is in the book, which is probably less relevant to today's topic. So I'm going to skip those. So this is what I'm going to do. So I'm going to tell you what is the background. So what is the motivation, and then what is the methodology that we have used, and then I go very quickly to the results, and then what I'm going to say something about what it means and how do we interpret those results. Then I will go very, very high level into the research snapshots, highlights of selected researchers, typically 8 of them. And then I will also go through a list of recommendations that we made to DST, the Department of Science and Technology. And then I will probably add a little bit on some of the new research or activities which we believe was quite a bit influenced by the research results that we have conducted in this report. So finally, some conclusions. So as an introduction, so this is the big background. So energy efficiency, firstly, International Energy Efficiency Agency estimate that whatever you do in energy efficiency, so you have a benefit of a ratio of 1 to 4. And South Africa per capita energy consumption is actually quite high if, on an international standard. So if you look at that as a function of per capita GDP, is about twice of the international average. But the electrical energy is about 40% higher than the international average. So it's actually, the situation is quite bad. But then Eskom is South Africa's electricity public utility. It is the only major public utility in the country. It was established in 1923, and then itself also administers the energy efficiency or energy saving program since 1990s. In the meantime, South Africa has developed some solid measures or metrics to support the energy efficiency accounting. So following largely the International Performance Measurement and Verification Protocol. And then South Africa is actually the first ever country that produced a national standard for measurement and verification. So in South Africa, this is labeled as SANS 50010. So this is the big picture. So the situation is very bad, but then in the meantime, South Africa believes that the energy efficiency as a country is doing quite well. But this is all based on the SAMSAC. So then in 2017, then there seems to be a need from the government side to see whether we can do a more vigorous, more detailed study, which provides an overview based on solid data. So what is the South African research productivity in terms of energy efficiency of various fields using the public data? And then they want to do it for a considerable time span. And eventually we decided to do it over 30 years from 1986 to 2016. And then, as I said, that the study was coordinated by the Academy of Science of South Africa, but it was mandated by DST. And then, obviously, the idea is to see what is the current status, and then how we can use the current status and then guide the further research development directions in South Africa. So let me just quickly go through the methodology, and then very quickly then we agreed among the government and the Academy of Science to use Scopus. There are a couple of reasons to use Scopus, because Scopus has got some very large tools to use to track and analysis and visualize the data in a lot of details that we want. And then you can also filter out, and then you can do a lot of fine detailed analysis. And then it can also isolate the result for each country, because this is what we want to do. We want to do that for South Africa, but we also want to benchmark across the world. But in the meantime, it can also show the patent-related research. So this is the reasons that we use. But unfortunately, we cannot use other data which is available to us. For instance, some data in the private industries or private organizations. But unfortunately, because of a lot of organizations, and especially the industrial sectors, they don't want to go public with their data, so we cannot use them for that moment. So we have to skip those data, which is not in the public domain. So then we have decided that a number of steps that we go through. The first step is we want to collect a comprehensive list of keywords in the fields related to energy efficiency. And then we also agree that we're gonna select the keywords from these 4 sources. So International Energy Agency, and then the National Energy Efficiency Strategy of South Africa, which is a strategic document, which is very widely read in South Africa. And then we've got also a South African energy document, which is also a government document. And then a large number of academic papers. So that is available on Scopus. Then the second step is that from Scopus, then we decide to benchmark South Africa in Scopus with 4 groups of countries, as I mentioned a bit earlier. So we want to benchmark that, compare that with developed countries, and we want to particularly compare that with the BRICS countries. And then at that time, we don't know which countries are both best performing, but it turned out that we want to compare it with best performing countries, which turned out to be China and Iran, because of due to the number of publications that I will explain a bit later. And then we also want to benchmark more or less with countries at the same level of development, we believe, with South Africa, which turned out to be Egypt and Thailand. So overall, so we select these countries. So United States, China, Russia, India, Brazil, Australia, Egypt, Germany, Iran, and Thailand, just to compare across the board. And then the third step is to identify the broad field guided. This is guided by electrical energy efficiency, but largely also guided by the DST's instructions. So we have decided to choose the following 10 areas just to do the analysis. So smart grid, solid state lighting, industrial energy systems in mining, metallurgy and minerals, so triple M processing, and an integrated energy system, building energy systems, energy storage, energy system, power systems, renewable energy, measurement and verification, batch chemical processes, and tribology. So this is, as I said, is guided by the Academy of Science and the DST. And then the final step is that we want to somehow to make sure that this is the balanced selection of everything in terms of keywords and the research field. These balances are in terms of established field with emerging fields, or restructuring fields with declining fields, or the general area with subject area, the old versus new, and the strong versus average. So then I said earlier that we agreed that to do a 30-year study. So let's just quickly go to the result. So this is the general results in graphics. Obviously, down there's a big database that we've done. So this tells you the number of publication, each of these 10 areas for these 30 years. This is the South African data. So then if you see this plot, then it's got 10 curves. So each one represents those 10 areas, like industrial energy systems in M, etc. But if we go into a little bit of detail, so you could see from the picture that we've got the four colored areas. So the first area represented by a single field is M, so industrial energy systems. So this is traditionally the largest and the traditionally strongest South African research field, because South Africa is a mining country. The second category we can largely call it microgrid, but it includes 4 sub-areas like renewable energy, power systems, integrated building energy systems, and energy storage. Then a third area includes 2 areas, is solid state lighting, and then the other area is chemical processes. So we could see that all these areas, they perform a bit differently. In the second category, they are very strong, but they all go hand in hand. In the second category, we could see a contrast between solid state lighting and chemical processes. Especially chemical processes, there's a lot of fluctuations. So it tells us something about the chemical processes and solid state lighting. And then the final category is, you could see that some of them has got only half a curve. So they are all emerging energy research, energy efficiency fields, like a tripology, smart grid, and MMV. So it consists basically 3 areas. So these are the more, in terms of numeric figures. So this is the number of publications, patents in South Africa, and the percentage contributions in each of these 10 areas. But I also listed here the other countries. So if you look at the world total number in the first category, industrial energy systems in M, so we're looking at about 65,000 publications. Remember that this is all the articles in the Scopus. And then South Africa is 3,872. And then United States, you're looking at about 14,000. China, you're looking at about 11,000. Germany, look at about 30,000, etc. So roughly, you can get a feeling that the US accounts for about 22%. China accounts for about 17%. Germany, about 5%. And if you move down a little bit, Australia, 2%. But if you look at the percentage of South African contribution, is about 0.6%, 0.596%. So this is a true reflection of this particular field. Okay, you can also look at other fields like renewable energy, power systems, integrated building energy systems, energy storage. So I've got these different color codes, which tells you that they sit more or less in the same category. And comparing with the other ones. One particular one, like measurement and verification, the last column. So this is a very, very small field and a very, very new field. Overall, then you have less than 10,000 papers, but South Africa contributes about 89. So it's a very small field, but in terms of percentage, then South Africa contributes about 1%. So it reflects that in this new field, South Africa might be very strong in terms of measurement and verification. And then, of course, then you've got also the number of patents. I think in terms of patents, then I've got these figures. I think in terms of South African contributions, then which is slightly lagged behind the formal papers. So these are the two views that are going a little bit into detail. I will show all the figures in there. I will go very quickly into interpretations. So the number of publications, that the first graph is in triple M, and then the second subset of graph is for renewable energies. So probably from here, you won't be able to tell something, but let's just go to a country-to-country comparison. So this is the country in terms of the groups. So if we look at the developed world, the US, Germany, and Australia, so you could see that they are doing better than the rest of the world. And then also, you can also group these BRICS countries together. You could see that these 5 countries, they are also in a large group, but then 3 of them are doing more or less the same because their curve is more or less in parallel. And then it's just China and Russia. So these stands out, so they are breaking the trend. So I'm probably gonna tell a little bit about that one a bit later. And then the best performing country, we could see that Iran and China is doing really, really well. But because if you look at the curve, they are actually accelerating over this 30 years period. And then if you compare South Africa with Thailand and Egypt, so they are basically these 3 curves are intertwined with each other. So it really tells you that so we are on par with Egypt and Thailand. And then the other thing that I want to just also take it out to see, just to compare, I said China is doing good, but let's put South Africa, United States, and Germany and China in one picture. So you could see that South Africa, Germany, and the United States, so these 3 curves all more or less in parallel. So on average, so we are doing as good as the developed countries. But China is accelerating, I think, to about 2001, they already passed Germany, and then get to about 2010 or 2009. So the total number of publications already passed the United States. So the overall, the total number, they are still lagging behind. I said that they are about 17 versus 22 of the US, but we could see that they are breaking this trend. So these are all the other fields, other 8 fields. I'm not going to go into detail, but they are more or less the same, except for the new fields. So we could observe a lot of interesting things. I have already mentioned a few, but we could make a few more observations. So you have the strong areas such like industrial energy systems in mining, mineral and metal, and M&B. So these are true reflections of South African research excellence. And then South Africa follows more or less the broad international trend. So on average, there's accelerated growth in solid state lighting and also slight decline in chemical batch processes, where the emerging fields like tribology, smart grid, and M&V shows rapid growth. And the number of publications in South Africa in energy efficiency has been increased consistently from 2007. And then it reached a peak at about 2007, 13 or 14 in most of the areas. And then it starts to stabilize a bit, and then maybe also a bit decline. I think that this is also a global trend. We see that we observe that this is a global trend. So it might be locally, we know that is correlated to the increase and decrease of funding. But we suspect that internal support from the universities could be also another parameter, but we are not quite sure. So we just speculate. But in the chemical process, chemical batch process, we went a bit detailed to find out what is the reason of the fluctuation and slight decline. And then we realized that the important groups, and then the people reach retirement, and then there's a lot of institutional relocations of leading researchers. So, and then there's also a clear correlation between the country's performances and the maturity of the technology status, economic development status, policy support, and R&D investment. Then fluctuation we observed for developed countries very small, which demonstrates that the support.
State of research, development, innovation of electrical energy efficiency in South Africa. Xiaohua Xia.
Yes.
Please let someone is having the microphone on and disturbing the presentation. Can you please shut it off and mute again?
Okay, thank you, Eric. So may I just continue? Okay, so the BRICS countries, then we see that it's very, very unbalanced. So each country has probably chosen to support only a certain areas, but not all the relevant areas. So this is also clear from China. So China, it's also, I think some of the areas they are not covered, but they perform quite differently. And then the countries with the same or almost the same development status with South Africa show very similar trends in recent years. But South Africa and Egypt has dropped their rankings at this. We believe that this is a historic important moment. And then China and Iran stand out, as said. So they are best performing in terms of their LAMBO publications. They have increased the number of publications in the general field of energy efficiency and in all selected specific areas. And then they develop more rapidly compare the rest of the developing countries. So it can be expected that China and Iran are also the best performing in other areas beyond energy efficiency, but we don't actually know. It is also worth noting that this has happened over the past 30 years. And then I think that it gives a good reason to speculate that both countries, they experience this rapid economic expansion from a very low base. And it was also demonstrated in the benchmarking section of the result. China as a country was below Australia between 2001 and 2003, but it was able to become the leading country in energy efficiency research. On the other hand, Russia's contribution towards the world's research output has fluctuated in the last 20 years and has declined in relative terms. So we also see a strong correlation between South African research excellence and the national uptake and the impact of actual implementation of energy efficiency interventions. So we could see very clearly that whatever is strong in research for South Africa, and then the industrial implementation is also very, very strong. And then an international cooperation and agreement contributes to this research and the technology establishment. And then the implementation of energy efficiency technologies are sometimes visible from various public sector sources, such as the scorecard and in the IEA and the country-specific case studies. But in South Africa, various technology-enabled energy efficiency and demand-side management options was examined and implemented. But this include, but not only limited to the following: load shifting, smart metering, and time zone, switch lights, switching off street lights, etc. So actually, seen as in my center, we have compiled a report in around 2015. What is the uptake time frame and a saving potential for a typical energy efficiency? So I won't be able to tell that at this moment. So the research areas, I think we could see that these universities, like University of Pretoria, University of Cape Town, Stellenbosch University, University of KwaZulu-Natal, so they are all featured in these areas. And then I also listed here the top 5 researchers in each of these 10 fields. So I want to just choose 8 of them just to go through to see what is the research highlight of them. So starting with the power system group in the Department of Electrical Engineering at the University of Cape Town, we have Professor Soletro Chaudhary. So her research area is renewable energy systems, distributed generation, power system protection, microgrid, and smart grid. And she's got a NRFC rating. And then I listed here some of her typical papers. So just one sentence about the paper, the focus of the paper. So one of the paper, for instance, studied the planning of combined heat and power-based microgrid and its distributed energy resource capacity. So I think she's been doing very, very well. Because of time, I would probably just move a bit faster. So going to the next one is Professor Unzulaman Kenneth in the Department of Chemistry at the University of Witwatersrand. So his research area is energy storage, fuel cells, and electrochemical sensors. And then also Professor Joshua Mayer from Department of Mechanical and Aeronautical Engineering from the University of Pretoria. And his research areas is more in experimental thermal fluid dynamics, enhanced heat transfer, convection heat transfer, condensation heat transfer, etc. So he's an A-rated scientist from the NRF. And then we have also Professor Swart, B-rated from the Department of Physics from the University of Free State. And his research area is the flat panel display, nanotechnology, organic electroluminescence device, so organic photovoltaic, formation of nanoparticles. And then we have Professor Toko Mojosi from the University of Witwatersrand, School of Chemical and Metallurgical Engineering. So his research, he's got a B rating, and his research areas is batch chemical processing integration, sustainable process system engineering, mathematical modeling. And then remember that this School of Chemical and Metallurgical Engineering is a traditional, very strong school. So you've got other important people like David Glasser and Diana Hildebrandt. So this is where I mentioned that because David and is retired, so there's a lot of fluctuations or change. But then Professor Toko Mojosi took up the position, so it's catching up very, very nicely. And then also Professor Hanke, Harold Hanke, from my department, Department of Electrical, Electronic and Computer Engineering. Then his research areas in electrical utility environment, safety and underground mines, smart networks. So he's leading our advanced sensor network research group, and he's doing extremely well in terms of energy efficiency in the sensor network area. And then energy system group led by Professor L.J. Robler from the University of Northwest University in the Department of Mechanical Engineering. So he's basically the godfather of measurement and verification in South Africa. So he single-handed brought measurement and verification from EOV to South Africa. And since then, he's leading this group. So that's why I think that South Africa is doing extremely well in terms of measurement and verification. So lastly, in my group, so we have the Center of New Energy Systems. And then since about 2008, so we are selected to host the National Hub for Energy Efficiency and Demand Side. So this is the postgraduate program as introduced by Eric. But we also collaborate with SENEDI, the South African National Energy Development Institute, and Exara, which is a coal mining company. And then through a number of companies, then we offer the service in terms of energy optimization and standardization. So our research areas may be a little bit less focused, but is quite widespread because we've got the hub running across a number of research groups. So we have power systems, industrial energy systems, building energy systems, and we also do measurement and verification, social effect, etc. And then we are currently very active in terms of these 4 topics, like P2P trading, microgrid, supercapacitors, energy, water, food, access, which is the panel topic of this morning. And then there are some figures about our achievements, like that I mentioned that we are awarded to host the National Hub. And then we also got the chair of energy efficiency from Epsora. So we published quite good over the past 10 or 15, 12 years. And then we have a large number of practical projects and students. So this is a recommendation based on this research that we did we made it to DST. So we said that both the design and implementation of national energy efficiency strategies require significant support from research activities. For instance, technology transfer, localization, innovation, investigation, market transformation. So also we said that this type of research in energy efficiency is applied in nature. So it is very different from the basic research and the isolated gadget type development. So, so these type of research call for integrated and systematic research efforts close to the market and society. Also, we said that these research activities are supposed to provide comprehensive evaluation of national energy efficiency saving potentials. And then we need to use to design prioritized EEDSM policies and solutions, implement energy efficiency improvement in the field, conduct accurate quantification of EEDSM policy and program impacts. This should be done with well-documented surveys of the market penetration and transformation, sufficient energy data. So we said this one because in the background, we have a very good collaborations with Lawrence Berkeley Lab in this field in terms of policy and program impact evaluation. And also we propose that advanced energy efficiency technologies such as those identified in this study has been transferred to South Africa gradually. But many of these fields, we found that the manufacture factories of such devices or such systems with local materials has not been somehow visible in the country. And then there's very few local technology innovation framework established. So based on this, we also said the government needs to support the important role to spur clean energy technology innovation and bring emerging technologies to the market. And then the research activities and evaluation and market transformation require strong information, data, and budgetary support from the government. However, in the South African context, EEDSM related research activities are only conducted voluntarily in some education and industrial institutions, and a very, very limited budget support. We also said that there's probably a need to build a data sharing platform. We said that we need to bridge the gap between national strategy and its implementation. And we also recommend that we should not just borrow directly implementation model from developed countries, because there's a discrepancy in knowledge skill, maybe the culture. And then, so in South Africa, typically we have to have operational units that helps to implement the energy efficiency framework. So under the current framework, the ESCOM, there's a unit called IDM has been taking the lead for this program over the past decade. This is doing extremely well. And then they actually developed some very nice products like the ESCO model, standard product or standard offer or performance contracting, these kind of things. You can, they sell it like this product. So you enter into a sales agreement with ESCOM. So it's very successful. But there are also other programs operating at the municipality and the private sectors, but their effectiveness was, I think we still need to strengthen that part. The same is true for the policy framework. So the outcome, so we don't have a full follow-up of the outcome, but we can just based on our knowledge. So the government has probably listened to us. So especially we observe, for instance, that in South Africa and Egypt joint call for research and innovation project. Then they start talking about you need to have a pilot, you need to have a proof of concept, and then the finalized technology need to clearly show and motivate the potential for South African and the Egyptian market. Also, I think for ourselves, our research was quite a bit influenced by this research report. So for instance, that we shifted a lot of our research into PVs and wind, and also supercapacitor is one of the areas that we identify that South Africa should take advantage of that, because we've got those materials to make the supercapacitors, everything. So I think with this one, I have about 7 minutes left, so I will just go very quickly to see that these two fields, I believe, which are somehow influenced by this type of research. The first one is our own research in terms of supercapacitors. The other one is the climate change, policy changes in terms of research in climate change. So very quickly, I'm going to go through this one. I'm not a typical expert in supercapacitors, but I have a very active group in my center. So they are doing very good studies in my view in terms of modeling of supercapacitors, but in conjunction with the manufacturing materials that is available in South Africa. So if you look at supercapacitors, you've got all these good features. So fast charging, fast discharging, high power, even though low energy density. And then also the operating temperature is very, very, very good. So it's from -40 to 70. Then it's eco-friendly and safe, so you can dispose it quite easily. And then the duty cycles or the charging and the cycles could be up to 1 million. And then the supercapacitor is somewhere between the conventional electrical capacitor and the electrical chemical cell. So some of the indicators that you see that the supercapacitor charges and discharges very, very quickly in terms of seconds or tens of seconds. But comparing with the normal battery, you can go up to hours. But if you look at the power, so the specific power, for instance, that the power density, so the per kilowatt of hour, so you can go up to 10 kilowatt. And then the specific power for battery is probably less than 1 kilo. So these are the good features that we have. So that's why supercapacitors, you find supercapacitors in a lot of real good applications. I think let me then give that to as a basic introduction, and then let's move quickly to what we have done. So the first thing we have done is a 3D electrical equivalent model. So we want to build a model so that we can do a modeling of the electrical properties of a supercapacitor. So I think we want to build it in a 3D version so that each one of these parameters has got a physical meaning. So for instance, that there are a couple of resistors. So in particular, so we have, say, for instance, that one of the resistors is the resistance of the electrolyte. And then another one can be the resistance of the membrane. And then another one could be the current collector. And then also the leakage resistance, etc. So with this one, then we can simulate at least using MATLAB or computer to see whether it makes sense. So this is what we simulated the model using typical parameters, and then we went to the lab testing with the real South African materials. Then we could see if you. I couldn't put it in the same page, but if you could see that these three pictures, they mimic with each other from the simulation and the experimental setup. So which is actually quite good. And then with this one, we can, the idea is to build this model so that we can select the optimal material for specific construction of the battery, so that which is optimal for the local production. So I think that this is also sensible in a country like South Africa, because I remember that I visited the Silicon Valley, and then one of the small company in there, so they can just get all the materials and then they start doing the testing. But in South Africa, we don't have all the availability of the materials, but we only know the local materials. So we developed this model. So this model may be locally, then it is, we can develop a local deviation model, which can reflect the local materials. So I think that the idea of this modeling exercise is to increase the outcome capacity and to facilitate the local design processes. So the previous research only tried to explain different kinds of electrical circuits, but then none of them clearly relates each of the components to the final material or to the final energy, stored energy. So I think that this model, so to our belief, is going to provide some kind of deep understanding of the electrical behavior of the supercapacitor. So I give you two applications of this model. So the first one, we need to say how we construct these models. So I'm going to move a bit quickly. So we collect the material, and then we also organize the electrolytes, and then we do the design. So we make the supercapacitors different designs so that we can fit into diverse or different applications. So two of the studies that we've done is to see the influence of the microwave radiation on the electrode material. So we've done the construction of the supercapacitor based on this material, and then we do also the experiment. And the other one is that we do that the radiation with the exposure on the full cell, like a radiative from the material. So we also do the experiment and the construction of this. And then we can observe from these the initial improvement of this experiment and the construction. So the electrical chemical performance of the symmetric device could be linked to the self-reorganization of the carbon nanostructure. Because once you put in a microwave, then the structure becomes a bit uniformed, and then that gives you improvements of the electrical chemical performances. So we also, it has been reported that electrical beams of sufficient energy can improve the nanocrystallinity of activated carbon material. So this also helps us to explain why if you activate the electrons of the supercapacitor, it also improves the chemical electrical performances. So based on this assumption, we could see clearly improvement of the chemical, the material conductivity and the crystallinity of the material. Then an interesting part of this one is these results, we could use this 3D model to predict exactly if we decrease some parts of the parameters of the model, it matches exactly with these kind of predictions. So these 3D model, so we can at least use for validation of these actual manufacturing design. We've got other areas application. I saw that my time is almost running out. So I'm going to skip this part, and then I go just very quickly to say the climate change. So this one, we also think that it is somehow influenced by that research report. So I think that the climate change is already a measurable reality, posing significant social, economic, and environmental risks and challenges globally. So like everywhere else, South Africa is especially vulnerable to the impacts of climate change. So then in such, South Africa has a task of balancing the acceleration of economic growth and transformation with sustainable use of environmental resources and responding to climate change. And then, as we mentioned, South Africa was the 14th largest emitter of greenhouse gas, and its CO2 emissions are principally due to heavy reliance on coal. And however, the recent released draft electricity plan proposes a significant shift around away from the fuel towards gas and renewables. And but in South Africa, coal is still going to be a dominant fuel for decades. So the solution, we all know that is mitigation and adaptation. So these are the standard measures if you go through the international best practices. So how do you do the mitigation and the adaptation? So you have practice energy efficiency, then the greater use of renewable energy, and then you optimize industrial processes, and then you transform your transportation, and then you impose carbon tax and carbon reduction. And in adaptation, also you look at more secure facility location and infrastructure, and the landscaping, and a flexible and diverse cultivation to be prepared for natural catastrophes, and a research and development and possible improvement of existing resources, water, food, and energy, and a preventative and a precautionary measures. So if you link this with South African research effort, so we have seen that there is a much more focused study now in these fields, like a practice energy efficiency, renewable energy, industrial processes, transportation, carbon tax, and water, food, and resources. I think that this is we are very happy to see that this is actually very much influenced by that report that we did for the DST. I think that with this, I would like just to say thank you for your patience. Hopefully that I tell you a good story about South Africa in terms of energy research and implementation. Thank you very much.